here are a couple examples of rational equations that are going to result in having to solve a quadratic. So this first one, we're going to start solving it the same way we would if we were solving one that doesn't have a squared in it. So what I want to do is I want to get everything to the other side of the equation from the radical, or I want to isolate the radical. So I'm going to take away the 2n from both sides to start with. This is going to cancel out the 2n on the left and leave me with 2 times the square root of n squared minus 7. On the right hand side of my equation, I'm going to be left with 14 minus 2n. Now, because because both of these are even, I'm going to divide by 2 to get rid of my 2 here. So on the left-hand side, I have the square root of n squared minus 7. And on the right-hand side, I have 7 minus n, because I divided both the 14 and the 2 by 2. So I've done the first step, which is isolate the radical. I've gotten the radical by itself. Now to get rid of this radical, I'm going to square both sides. But you need to be cautious. When I square the square root, all that does is get rid of the square root. So I end up with n squared minus 7. But on the right-hand side, 7 minus n squared is 7 minus n times 7 minus n. And I need to multiply this out using the distributive property. So 7 times 7, 7 times n, and then n times 7, or negative n times 7, and negative n times negative n. So what that's going to result in is 49 minus 7n minus 7n plus n squared, which when I collect like terms is going to be 49 minus 14n plus n squared. Now in order to solve this, I want to get everything on one side of the equation, or I want to make the equation equal to 0. But when I take away n squared from both sides, it's going to cancel out both n squareds. So luckily, that leaves me with a linear equation. Negative 7 equals 49 minus 14n. So my second step here, just like we did in the previous examples, was to square both sides. And then my third step is to collect like terms and solve for n. So now I'm going to take away 49 from both sides. I get negative 56 equals negative 14n. Finally, I'm going to divide by negative 14. And that's going to leave me with n equals 4. Now once I've solved for n, I do always have to do the last step, which is check my work. So my original equation was 2n plus 2 times the square root of n squared minus 7 equals 14. So I need to substitute the 4 in there. I've got 2 times 4 plus 2 times 4 squared minus 7 equals 14. So 2 times 4 is going to be 8. This is going to be 2 times 4 squared is 16 minus 7 is 9. Take the square root. I'm going to get 3. So of course this one is correct. N equals 4. Now here's an equation that we already have isolated the radical. So the first thing I'm going to do is I'm going to square both sides. So when I square both sides, the square and the square root cancel out, and I just end up with d plus 5 on this side. On the other side, I have to multiply out d minus 1 times d minus 1. So I get d plus 5 equals d squared minus d plus 1. And collecting like terms, I get d squared minus 2d plus 1. So the first thing I did was square both sides. The second thing I had to do was expand and collect like terms. The third thing I have to do is I need to make the equation equal 0. Because it's a quadratic, that's the only way I'm going to be able to solve it. You can only solve quadratic equations if they're equal to 0. So in order to do this, I'm going to subtract d from both sides. And I get 5 equals d squared minus 3d plus 1. And now I'm going to get rid of the 5. So take away 5 from both sides. And I get 0 equals d squared minus 3d minus 4. Now, lucky for us, this can be factored. So my last step is we're going to factor and solve. If it can't factor, we're going to use the quadratic formula. So in this case, it can factor. We get d minus 4 and d plus 1, which means d equals 4 and d equals negative 1. My final step is I need to check. So I use my original equation, square root of d plus 5 equals d minus 1. So we have the square root of d plus 5 equals d minus 1. And when I substitute in the 4, I get 4 plus 5 equals 4 minus 1. Well, 4 plus 5 is 9. The square root of 9 is going to give us 3, equals 4 minus 1, which is 3. So 4 is a solution. 4 will work. If I substitute in the negative 1, I get negative 1 plus 5 equals negative 1 minus 1. Negative 1 plus 5 is 4. Take the square root, I get positive 2. If I take negative 1 and negative 1, that doesn't work. So this value here is not a solution, and we call it extraneous. So the only solution to this equation is d equals 4. Now finally, the most challenging one. Here I have two square roots, but in this example, I've got a 1 here, which is going to mess it up when I square it. So to get rid of my first square root, I'm still going to square both sides. So on the left, it's quite simple. I get rid of the square root, and I get 2y plus 3. But on the right-hand side, I've got 1 plus y plus 1, and another 1 plus root y plus 1. Now I have to expand that out. So I'm going to go 1 times 1, so my 2y plus 3 is still here. 1 times 1 is going to be 1. Then I'm going to go 1 times root y plus 1 is going to give me root y plus 1. Then I'm going to move to the inside. Root y plus 1 times 1 is going to be root y plus 1. And then finally, last, root y plus 1 and root y plus 1. When I multiply a root by itself, it just gets rid of the square root. So I end up with y plus 1 on its own. Now I'm going to collect all my like terms. So I got 2y plus 3 equals 2 plus 2 root y plus 1 plus y. Now I'm going to start repeating the steps. So I've got another root. I need to isolate that square root. So I am going to take away the 2 from both sides, and I get 2y plus 1 equals 2 root y plus 1 plus y. Now I'm going to take away a y from both sides, and I get y plus 1 equals 2 root y plus 1. Now I could divide by 2 to get rid of the 2, but that's going to leave me with an ugly fraction. So I'm just going to leave it where it is. And I'm going to square both sides. So on this side, I've got to write it all out. On this side, I'm going to be left with 4. Now the square root's going to go away, so I'm just going to have y plus 1. Now I need to expand. Y and y is going to be y squared plus y plus 1. On this side, it's going to be 4y plus 4. Then I'm going to collect like terms and move everything over to the other side. So I'm going to be left with y squared. I'm going to take away a 4y here. So y plus y minus 4y is going to give me, minus 2y. I'm also going to take away a 4 here, and I'm going to get minus 3 equals 0. Now thankfully this can factor. So I got y minus 3, y plus 1 equals 0, which leaves me y equals 3, and y equals negative 1. Now my last step is I need to check. So if we go all the way back to our original equation, we get the square root of 2y plus 3 equals 1 plus square root of y plus 1. So I'll put in my first solution. I've got 2 times 3 plus 3 equals 1 root 3 plus 1. So 2 times 3 is 6 plus 3 is 9. Take the square root, I get 3. Over on this side, 3 plus 1 is 4. Take the square root, I get 2 plus 1 is also 3. So that one works. So y equals 3 is a solution. But I also have to check the other one. 2 times negative 1 plus 3. Take the square root, that's going to give me 1. This one, negative 1 and 1 is 0. Take the square root, plus 1. I also get 1. So that one is also a solution. So in this case, I have 2 solutions.